Okay, this week, for the second part of probability, we're going to be looking at counting techniques. As you recall, the probability of an event is the number of favorable outcomes to an experiment divided by the total number of outcomes to an experiment. Well, sometimes it's not that easy to count how many outcomes there are in an experiment, and we need to learn some counting techniques. Take the example of the Pennsylvania daily number. There's 3 bins of balls. One bin has 10 little ping pong balls numbered from 0 to 9. A second bin has a second group of 10 ping pong balls numbered from 0 to 9. And a third bin has 10 balls numbered 0 to 9. Now they draw 1 ball from bin 1, 1 ball from bin 2, and 1 ball from bin 3, and they make a 3-digit number. How many possible outcomes are there? Well, there are 10 different ways that outcome 1 could happen. The ball could be drawn from bin 1. And then with every ball in bin 1, there's 10 different outcomes in bin 2 that are possible. And then 10 different outcomes in bin 3 that are possible. So we're going to multiply 10 times 10 times 10 and get 1,000. There are 1,000 different daily number possibilities. So this is what's known as the multiplication rule. If an outcome is generated by selecting one item from different groups of items, then we can use the multiplication rule. And I give an example here. The Phillies have 3 different uniform pants and 3 different uniform jerseys. How many different uniforms can they wear? Well, there's 3 pants and 3 jerseys. They can wear each pants with each jersey. There's 9 different possible uniforms that they could have. Here is a different scenario. Let's say there was only one bin of 10 balls, and we were going to select 3 balls from that one bin. So we would select one ball, then select a second, then select a third, and make a 3-digit number. Now for this scenario, assume that if a 5, a 7, and a 2 are selected, that if the 7 gets selected first, then the 2, then 5. Let's assume those are different outcomes. How many different outcomes are possible? This scenario is called a permutation. This is where we select many items from one group of items, and that the order of the outcome is important. A permutation is a counting technique where we take the number of items, and r is the number of items we're taking at a time. We take n factorial and multiply or divide it by n minus r, quantity factorial. So in this, we have 10 balls, and we're selecting 3 at a time. So it's 10 factorial all over 10 minus 3 factorial, or 10 factorial all over 7 factorial. Now factorial is a shorthand. It simply means 10 times 9 times 8 times 7, all the way till you get to 1. So we end up with 10 factorial all over 7 factorial, or 720.